Okay, Chapter 8 review. Number 1. A study of the IQ of husbands and wives obtained the following results. IQ 100, SD 15, IQ 100, SD 15. Well, guess why that's the case? That is how IQ is defined. So they take everybody's scores on the IQ test, and then they adapt them so the average becomes 100 and the SD becomes 15. It's kind of like standardizing, where we make the average 0 and the SD 1 and -1, only you do 115. So it's not surprising that that's the case. But an R of 0.6. One of the following is a scatter diagram for the data. Which one is it? Why is it not A? The average is in the wrong place. Okay, A has average, the point of averages is at 50, 50. That's not right. Why is it not B? The SD is too small. Okay, all of the data is within about 20 of 100 in both directions. Okay, why not C? No, C, it's not an SD problem. It's the correlation coefficient problem. The football's the wrong shape. What would you guess the correlation coefficient for C would be? 0.8, 0.9, 0.95, somewhere in there. It's certainly higher than 60. So the answer is D. And well, I guess you're also right, Megan. The SD would not be 15. So yeah, I'll give you that. Okay, so D is the answer. Number 2, for a representative sample of cars, would the correlation coefficient between the age of the car and its gasoline economy be positive or negative? So the older the car becomes, what happens to its gas mileage? It goes down. So as X gets bigger, Y gets smaller, the correlation coefficient would be negative. Okay? The correlation between gasoline economy and income of owner turns out to be positive. How do you account for this? Yep. People with more money can afford newer cars. Well, but it's the average miles per gallon per car. So that, yeah, that's not gonna change it. So people like me drive old trucks that don't get very good gas mileage. And for people like Josh, he bought my old truck from me when I got my used one. So, and actually he didn't buy it. His brother-in-law bought it for him. Okay, number 4. Is the correlation between the heights of husbands and wives in the U.S. around negative 0.9, negative 0.3, 0.3, or 0.9? So we don't have any data, but let's draw it. If I had husband's heights here and wife heights here, what's the scatter plot going to look like? So let's call this the point of averages. Okay. As we look at taller husbands, what sort of people do tall men usually marry? Tall women. You so so let's see. You can certainly think of opposites, but how many of you have tall dads, taller than average, 5'9" or more? Okay, so about half of you have dads that are 5'9" or taller. How many of you have moms that are same people? Okay, how many of you have moms that are 5'2" or taller? The same amount, but that's average for women. Okay, 5'4". I'm 5. Okay, well, so again, if your dads are 5'9" or taller, raise your right hand. Okay? Only those people who have their hands in the air. How many have moms that are 5'4" or taller? Raise your left hand. And yes. See, now look at that. That's almost everybody. Okay? How many of you have dads that are shorter than 5'8"? 5'8" or shorter? Just Dalton. Okay? Well, I'll include me in the list. Okay? How many, and then how tall are your moms? How tall is your mom? Oh, so there's one that doesn't fit the mold. How tall is your mom? Okay, so so um, if we were to look at the data, we would see a positive correlation because taller men usually marry taller women. Well, yeah, that's just how. I mean, are there really tall males that marry really tall really short females? Yeah, it certainly happens, but most husband-wife combos are within a certain height. So men are naturally taller than women on average. So I'm willing to bet that most men marry a woman within 6 or 8 inches of their own height. Okay? There just aren't that many really tall, really short, or the reverse. So it's going to be positively correlated. Is it going to be positive 0.3 or positive 0.9? Definitely 0.3 because it's going to be all over the map. Sometimes women are taller than men, not very often, but you'll just have to believe me the answer is 0.3. Now, that would be interesting to do. Maybe, are you guys interested in doing that, looking at your parents? Okay. We'll set that up when I'm done with this. Okay. Now number 7. Okay. In the figure below has 6 scatter diagrams. The correlation coefficients in scrambled order are that. So, graph number 1. What's that going to be? 0.62. The one to the right of that? -1. The middle one on the left? -0.85. The middle one on the right? 0.97. The bottom left? 0.06. It's just about a circle. Slight positive correlation. And then the last one? -0.38. Okay? And number 11. Okay, a teaching assistant gives a quiz with 10 questions and no extra credit. After grading the paper, the TA writes down for each student the number of questions the student got right and the number of questions the student got wrong. The average number of right answers is 6.4 with an SD of 2, and the average number of wrong answers is 3.6 with an SD of 2. The correlation between the number of right answers and the wrong answers is... So it's not this chart, by the way. That chart's for question number 12. So, okay. So the number of correct answers. Okay. As the number of correct answers goes up, the number of incorrect answers goes down. So it's going to be negative. It is -1. So does it say how many questions? So 10. So if I got one question right, how many questions wrong did I get? Okay. If I got 2 questions right, 8. 3 would be 7. 4 would be 6. Oops. right? There is no other option. You either got it right or you got it wrong, so the correlation is -1. Okay.